Here is another example in operation amplifier, and we know that if we want to solve a problem in operation amplifier, first we need to apply two things here. Number one, the current here is zero. The input current is zero. So this current is zero. This current is zero. So we have to know that. And the voltage here equal the voltage here. This voltage equal this voltage. Okay. And if this voltage here is zero, this is a ground. So this one is zero. So we know that this voltage here is 0 volt. So when you look at this circuit here, the voltage here is 0 volt. So we know this in advance. So of course, if we do that, then in this case, we actually don't care about the operation amplifier at all, because what we need to do is to solve this part here. And in this circuit here, we have a node here, V1, and we have a node here, which is connected to VO, so we can call it VO. So if we call this V1, we can call V2 if you want, but actually it is connected to VO, so actually it is VO. And this was required. We need to calculate VO. So this is the first step here, is to apply the steps to solve operation amplifier. Again, the input current is 0, and the voltages are the same. This one is ground, so this one is ground also. This one is 0 volt. Okay, so we know this. So in this case, we can avoid the operation amplifier as it doesn't exist. Then after that, we try to solve this problem. To solve this problem, you have to convert it first from time domain to phasor domain. Vs, for example, is 3 cosine 1000t. So this is omega. 1000 is omega. 3 is the amplitude. So it will be 3 and phase is 0. There it is. And you apply or you find the impedance for the capacitor here. The capacitor, we don't have inductor, so this one here, this capacitor and this capacitor. So it will be 1 over j omega c. 1 over j omega c. If you want to calculate this, for example, let's calculate one of them. For example, 0.1. What's 0.1 microfarad? It is 1 over j omega c. Omega is 1000, so it is actually 10 to the power of 3. Okay, time what? Time c, which is 0.1. Okay, 0.1 what? 0.1 microfarad, which means that you have a 10 to the power of 6 here on the top. 10 to the power of 6. 0.1 micro, so it is 0.1 times 10 to the power of negative 6. You move it up to be 10 to the power of 6. Then now you can cancel this one here with this one here, will be 10 to the power of 3 or 1000. 1000 divided by 0.1 will be 10,000. 10,000. So it will be 10 kilo actually. So it will be 1 over j, 10 kilo, or negative j. 1 over j is negative j, and it is 10k. 10k. So here's this one here. Okay. The other one will be 1/2 of it, 0.2 microfarad. It will be negative j5. Okay. Why? Because actually you divide by c, 1 over j omega c. So here we doubled c, we doubled it, 0.1, make it 0.2. So actually we decrease the impedance by half. Okay. Or you can just calculate it, 1 over j omega c, 1000, and c is 0.2 microfarad, and then you can calculate it. Then now we are ready to solve this problem. So we assume that this is V1 and this one we call it V out because it is already connected to V out. And we apply nodal analysis. Okay, so the first current here, forget about this red currents here. We do it in our way. So this current plus this current plus this current, you have 4 currents here, equals 0. So the first current is what? Is V1 minus V1 minus 3. V1 minus 3. Remember, this 3 is just 3 because it doesn't have any phase. V1 minus 3 over 10k, first current. Second current is V1 minus 0 divided by negative j 5k, and then V1 minus 0 divided by 10k, and then V1 minus VO divided by 20k, all equals 0. Of course, here you can neglect the k because all of them are k. For the second node, VO, pure VO, you apply this one here. Okay, so let's apply nodal analysis at this node here, because you cannot apply it at VO. You cannot apply the nodal analysis at VO. Why? Because you don't know the current here. Simply, you don't know the current here. So as I said, in circuit theory, you never apply nodal analysis at the output. So let's apply nodal analysis here, the second node, this one. We know that this one is 0, is ground. So it will be 0 minus V1 divided by 10K. Okay, so it is negative V1 divided by 10K. And this one is 0 minus VO divided by negative J 10K. Okay, and we know that the third current is 0. Okay, that's it. So now we have two equations and two unknowns, which is V1 and VO. We don't care too much about V1 unless it is required, of course. We care about VO, so we need to stress on VO if you want. So we need to simplify these equations. Of course, this one here is just multiplied by what? By 20. You just multiply the whole equation by 20. And here you just multiply by 10. That's it. When you multiply by this by 20 and this you multiply by 10, you get these two red equations here. Yeah, again, for assume that this is 10, you multiply this by 20 here. 20 divided by 10 is 2, so it will be 2V1 minus 2 times 3, which is 6. And here 20 divided by 5 is 2 is 4, so it will be 4V1. And negative J, you move it up, will be positive J. And then 20 divided by 10 will be 2, so it will be 2V1. And then 20 divided by 20 is 1, so it will be V1 minus VO. So here it is. When you multiply this by 10, 10 divided by 10 is 1, will be negative V1. Okay, so this one here is negative V1. And the other one here, what's this one here? Oh, yes, the other one, yeah. So this is negative V1. No, so it's not the red equation, sorry. The red equation is number 1, the black one is number 2. So this one will be negative V1. And then 10 divided by 10 is 1, so it will be negative VO, but negative will move it, negative J will move it up, will be positive, so negative J will be negative JVO. There it is. So this is the second equation. You simplify them more by collecting V1. You have 2V1 here, 2V1 here, V1 here will be 5. And you have J4V1, so it will be J4. Okay, so 5 plus J4V1 minus VO equal 6. You move this negative 6 to the other side. And this one you just multiply by negative, cancel this negative. So V1 plus JVO equals 0. So these are the two equations that you have. Then you apply Cramer's rule. So here's the first the coefficient matrix. Okay, and this is unknowns V1 and VO, and these are the constants 6 and 0. Then you find delta the same way. So J5 plus 4J times J will be 5J. J4 times J will be negative 4. And then minus what? Minus negative 4, negative 1 times 1 would be negative 1, will be minus 1 would be plus 1. Okay, so this will be delta. Delta look like this. And of course, we simplify it, will be J5, and negative 4 plus 1 will be negative 3. And then in this case, you convert this back to amplitude and phase. Okay. Then you do this one here. You replace the first column by 6 and 0. There it is. And for delta 2, you replace the second column by 6 and 0, and you repeat the same steps. Let me, for example, do the first one for you, delta. Delta. That's delta. So here you have 5 times J will be 5J, or J5. Okay, plus J4 times J. J times J is negative J, is negative. And 4 times 1 will be 4. So minus 4. And then minus what? Negative 1 times 1 will be negative 1. So it will be minus 1, that is plus 1. Okay, so this is delta. So it is what? It is actually negative 3 plus J5. Okay, converted to amplitude and phase, Then actually you have 3 square, which is 9 of course, plus 5 square, which is 25, equal 34, and take the square root to the power of 0.5 equal 5.8, almost 5.83. Here it is. Okay, what is the angle here? The angle is 5 divided by -3 equal, okay, and then inverse 10. Okay, inverse 10. 5 divided by -3, okay, equal inverse 10, which is this is the angle here. This is the angle here is different from this one. So which one is right here? Which one is right? This is, you have to think about it. This is 5 divided by -3. You have to be careful. Why? So the angle here is 59. So we know that this -59 is supposed to be like this. But the problem here is what? Assume that, for example, this one is 3 minus G5. Okay. So if you find 10 minus 1, the imaginary over the real, will be the same. 5 over -3, it is the same like -5 over 3. It is the same. Okay. So the calculator will tell you, give you an answer for them, for both of them the same way. So if I say -5, for example, 5 negative divided by 3 equal, and then say inverse 10, it will give you -59. Okay, so of course the angle here is different from the angle here. Okay, the angle here is different from the angle here. So which one we need to know here? We need to understand what is the angle. It is the imaginary, the real here is negative, so it's supposed to be here. The imaginary is positive, then this is the angle here. The vector like this. This is the -3, and this is 5. So the angle here is the angle. So the angle is supposed to be more than 90, between 90 and 180 degrees. This is the angle. Okay. For the other one, 3 is positive, so it is 3 here, and the -5, so it is here. So the angle is this one here. So it is this angle here. Okay. So for this one, this is the angle. And this is what the calculator calculates. It is -59. I believe it is -59 point something. I can't remember. Yes, -15, almost -59. Okay. Okay, so this one is -59. So in this case, we have to understand that the angle here is not -59 for the other one. No, the other one is 120, 180 degree, 180 minus this 59. Because the angle must be between 90 and 180 degree, which is 121. I believe it is 121 degree. This makes sense. So, okay, so you have to be careful when you have one is negative, one is positive. Why? Because the calculator does not understand which quarter the angle is. So the calculator here calculates this to be -59. Okay, so this means that it understands that it is actually in the 4th quarter. But according to what we have here, no, the imaginary is positive. The imaginary is positive here, and the real is negative. So the angle will be here. This is the complex vector here. So the angle, this is the angle. So the angle between 90 and 180 degree. Okay, so whatever you got, okay, subtract it to, or add 180 degree to it. You add 180 degree to this number here. So in this case, this will give you the right answer. So here it is 121. Okay. For delta 1, it was easy. J6 is 6 and 90. You know J is 90 degree. And for this one here is -6. You know negative is 180 degrees. So you can remove this negative and add 180 degrees. So now if we want to calculate V1, I need V1. So V1 is what? Is 1.029 and 59 degree. Then what you need to do is to convert it back to time domain. It is one point, the amplitude here is 1.029 cosine, and I know that omega was 1000. Omega was 1000 t plus the angle. which is 59. So this is VO as a function of time. So this will solve this problem.